our paper is titled Revealing and Interpret Complex Urban Patterns from Location-Based Social Network Data. And particularly, we're going to present today a first investigation of this broader research into the Chinese stadiums in the Global South. So this research is indeed part of a broader framework that a broader body of research that we call the Global Urban Network Research and Collaboration Lab, which is a laboratory at the University of Kansas, led by me and Gustavo. The lab aims at studying the intricate relationship between global architecture practice and their effects on the urban environment, and particularly focusing on the use of innovative urban analytic tools. With the center, we are establishing some partnerships at KU and outside KU, and so we are also working on a broader research with the Department of Architecture and Design at the Politecnico di Torino, and we are going to present today a small introductory part of this broader research. A little bit of the background from which this initiative and so this research comes from two main strengths or two main understanding of contemporary world. On the one hand, the complexification of the global architecture and urban production, and on the other hand, the evolution in the means of representation, visualization, and analysis of the urban environment. I'm going to give a short introduction to both of them. Indeed, the question or the challenge of transnational influence involved in urban production and city making is nothing new, but it's sometimes more evident or has different patterns in different times in history, so sometimes more than other. Nowadays, we are seeing different patterns indeed. For instance, rather than some years ago, we were used to a movement of transnational architecture and urban production, mainly from the West to the East and to the South, as this book, for instance, shows, but also as our understanding of the architecture production tells us. This is, for instance, is a map collecting all the architecture production cited in the book that I think all of us has used to study history for architecture, from Curtis, Scully, Frampton, Cohen, and so on. As you can see, is all moved on what we call nowadays the global north. But in the recent years, the production of architecture and urban environment has also changed with different movements, particularly from the east to the west and the global south. This is, for instance, a map collecting some recent production of architecture built and designed by Chinese enterprises around the world. So nowadays, in a world that has been described by many scholars as a multipolar world in terms of geopolitics, it's also a multipolar world in terms of architectural production. Thus, one of the aims of our broader laboratory research is to question through these transnational developments what are the new forms of spatial production, particularly of some unregistered and urban segment, to understand the contemporary global transformation dynamics, particularly looking at the urban transformations in the global south. On the other hand, we have a shift in what is our understanding and the tools that we have for understanding cities and urban transformation. This is an only map, we all know, in which the attention of this map is focused on the physical environment of the city, what is built and what not, the public spaces in this case. But with the spreads of the satellites in the 1960s, we added much more layers in what are the means of representation and understanding of city. So, for instance, this map of the Pearl River Delta shows how we can track human activities and having a better understanding of patterns of urbanization. So with the GIS, basically, we can have different layers from demographic to topography that help us on interpreting our urban environments. Then, with the spread of smartphones and sensors in general, with the network, we can also acquire different data and having also a more dynamic understanding of cities and urban environments, like in this example from Carlo Ratti in 2006. So as you can see from this graph, there's different layers and different data from this sensor that are spread in our world that we can collect and use to have an understanding of the urban environment. Nowadays, with the spread of natural language processing technologies, we are all used to hear about ChatGPT everywhere. Our research is also asking how this tool can be used to improve our understanding of cities and urban environments. So the aim of the research in this case is to collect and structure and interpret a large amount of data through the use of digital technologies and AI-based system on these newly urbanizing places we were talking about to foster a more data-driven approach for the study of the future cities, but also for the design of their transformation. I'm gonna now go to our case studies, which is mapping of what is called China Stadia diplomacy, just to show what are the first results of this broader research work. So first of all, it's a decade that what is called the China Belt and Road Initiative has started in 2014 by the means of President Xi Jinping. And this program, it's probably we all know, a large program of infrastructure in which China expenses over the life of the BRI could reach as much as $8 trillion. So this program that now including 150 countries has been deemed called the project of the century or the world's biggest infrastructure program ever attempted in the last 50 years. To give you a mean of the importance of this program in the world. As you can see, is touching different countries, but more relevant to us, the Belt and Road Initiative is bringing new construction, is bringing infrastructure, is bringing urban transformation and urbanization all around the world. That is what we are interested in. These are some of the examples of the buildings built by Chinese design, built by Chinese enterprises all around the world, from infrastructure, housing, venues, conference centers, sports facilities, and so on. However, this phenomenon is not new, but is part of a broader history of Chinese foreign aid diplomacy constructions in the world that started from the 1950s and went over to the 1980s until nowadays in different periods. So, for instance, as you see, there were already buildings in the 1960s, 1970s built by China in Southeast Asia or in Africa as a form of diplomacy. In total, China has built more than 2,000 projects all around the world in the last 50 years. And what catch the attention of me and Gustavo is that, as you can see here, there's different broader categories, science, education, that includes a lot of typologies of buildings, but stadiums is accounting the 15% of all of these projects, which is a relevant number. Indeed, this phenomenon of China's building stadiums form of a aid foreign construction is a phenomenon. It has also a name, which is called China Stadium Diplomacy, which is a form of subsidy practiced by this nation for building and financing the construction of stadiums and sport facilities in other countries. In the last 60 years, China built over 200 stadiums in the global south as this form of diplomacy. Here is a first recognition that we did. So this is the starting point of our research, is a database in which we started collecting all the stadiums that, as you can see, are mainly situated in the globe, in the southern part of the world. These are some example of the stadiums from Kenya to Tanzania, and as you can see, the impact of this object on the urban environment, also from a physical point of view, but not only, is quite impressive in terms of scale of the building, but also in terms of the transformation of the bigger plan that these stadiums carry on. So from this point of view, we are questioning what are the effects of these stadiums on the surrounding built environment, and particularly looking in places that usually evade the traditional mapping technologies. How we can bring a large amount of case studies into comparisons to identify trends and common patterns of development, and how Chinese stadiums can become a point of attraction or a repulsion force affecting socioeconomic activities. So these are some of the questions that are driving our research. And now I leave the stage to my colleague Gustavo, that is going to show better what is the method we employed and some of the results and findings of this study. Thank you.
All right, so thank you very much for having me here. Thanks, Francesco. I'm going to share my screen now with all of you. Okay, I believe you see my screen, right? Good. So then I'm going to carry on talking more about the method and what we have seen so far and how we have implemented this visualization method, and as well how we have incorporated or trying to use, which is a new development of this ongoing research, natural language processing models to become an interpreter of this, aiming to allow the everyday user to be able to touch the research. So this, as Francesco said, is an ongoing research, and before we understand that these kind of building this typology, or this type specifically, it's a type of building, stadium specifically speaking, if it's not well designed and very, very coherent and address the change of scale, it distorts space. A correct stadium, or a stadium that is aims to transform in a good way the urban environment, it generates this kind of pulling people together, or pulling people attracts people, and a stadium that's not well designed pretty much pushes people away. The matter of scale has this capacity in terms of stadia to distort the urban fabric in a way that attracts or repulses. So with that in mind, we start developing this methodology where we're pretty much here in this diagram, understanding that once you put the stadium in there, this large building distorts or creates this force up, down, up, or upwards, that creates this distortion in the urban fabric. And what we want, and this distortion pretty much, slides all the urban activity, everyday life, does not get to the highest point of this. The only people that gets to the highest point is the private sector. Everyday life or everyday city does not really go up there. So in this representation, what we're trying to aim here, it's pretty much this level of distortion of what we call in this level of placelessness. With that, on that front, we look into location-based social network data, which is pretty much data generated by all kinds of platforms that have some type of check-in or registration of your geolocation. This data is produced by the user. Once the data is produced and it's dumped into data lakes, we aim to access the APIs and then classify that data into types, categories based on a certain location, so we can feed this into an application. Breaking this methodology a little bit further, what we pretty much aim to do is to develop a software that we can instantiate a center or a point of interest, the user determines an area of interest, and then we start downloading all sorts of layers of data from the area, starting from the building masses Then we transform the street network into a graph, pretty much you've seen this around there. So we transform the streets into edges, the intersections into nodes. At that point, we can start running some calculations into the street network. Then once we collect all that data harvested from more than 20 data lakes, we transform this into a singular data structure, which is the hardest part of the work, and overlay this on top of the urban fabric or on top of the graph that represents the urban fabric. Once we do this, we connect those place points or those human activity points to the nodes. At that point, we're able to say that we have one single database with this overlapping of information or this enrich graph. And we can start running some visualizations. So we can start running some representations of the urban fabric based on nodes, edges, or anything that we start it's of interest. At this stage, we understand that we have what we call the 4D urban model because we can measure the destinations that we have around this large typology, the distances that they are in relation to this large building and to another types of activities. We also can measure the density of activities, not the density of people living in the area, but density of movement, density of activity, people visiting places, or pretty much circulating through the area. We can also imply or start using some other types of calculations, such as the diversity of activity that happens in the area. Once this data frame is put together, to break this down a little bit more further, this diagram shows how we are seeing the two graphs operating together. So the graph that you guys see in there that is represented by these dark gray nodes, what it shows, it's pretty much the nodes that represent the city. And we pretty much, once we collect the data, we are able to load that data into the entities on the urban street network to which we understand that data belongs. At the same time, this pinkish kind of color, we represent the graph of the urban activity or the activity that happens in the area overlaid on top of the city graph. All sorts of information or levels of data, which is represented in these boxes, are pretty much loaded into the graph. To make a comparison, as if we're given a DNA to each one of the nodes and each one of the edges. And once we overlay those two graphs, we have this dual graph, which is the socioeconomic activity and the urban and the social and the street network graph. And they're connected one to another. We have this urban graph, right? We were able to construct this urban graph that we understand that statistically give us a good perception of what the behavior, the urban behavior of that zone is. At this stage, we can generate so many visualizations. So these are all layers of visualizations that we can automate and generate based on this model. As you see from the left to the right, we can generate visualizations based on the urban graph, the socioeconomic activity. We can filter that socioeconomic activity to understand if certain things happen more than the other. We can then generate these kinds of visualization, which is pretty much simulations of the pedestrian routes or possible trips. Since we know what happens in the area, since we know what that ecosystem is, we can start understanding where people would normally go, what kind of exchanges between places in terms of trip would happen. At the same time, we can generate visualizations based on the nodes. We can weight them in relation to the data that we collect, and it's flexible enough so we can keep collecting data or enlarging the database with new data that becomes available. In this case, adding GPS data to the model that you guys saw before. At this point, we were able to ask so many questions. So here we're talking about shopping centers in cities around the world. What's their effect? What happens if they're able to attract people, if they're not, if they become really a center, a commercial center in the city or not, what's the relevance? We ask questions in terms of new architecture and urban design projects. People want to know how a certain area happens. This is England. What happens around here? This is an empty area, so we can design a new thing or start. There's an empty area in the center right there, which was supposed to become a park. New building types need to be proposed in there, so we can extract it from the data from this kind of data frame. At the same time, we can navigate to other parts of the world, identify centralities, see the relationship between socioeconomic activity, which is the yellow color on the bottom right, and the bluish color, which is GPS data, to see if there's any insights that we can extract from there. Now, since we can ask so many questions and there's this certain flexibility into this platform, we start looking into this. I was interested me and Francesco to look into this Chinese stadiums and see if we can first keep the standard collection of data at the same level, and at the same time, what kind of insights can we reveal from these stadiums that everybody knows exist as a geopolitical framework, but we really don't know anything about them. To break it down further, how we see that we are that this new improvement or this new step on the research in terms of adding natural language processing models to it, we understand that what happens now with traditional modes of analysis in terms of the urban space are pretty much depicted as this diagram. You need this very specialized user that runs a data collection, runs a data preparation with cleaning, georeferencing, and all of the standardizing the data pretty much and understanding its solidity. Then we have run spatial analysis and data visual and mapping and all kinds of analysis. Then it goes into simulation and modeling. Then it goes into reporting and generating complex reports. This is extremely heavy program, so you need a specialized person to run programs. That's ArcGIS, QGIS, ArcGIS visualization tools, Photoshop, InDesign. That goes back to the specialized user, which is who makes the interpretation to the general community. What we foresee now is that the user now creates the input or establishes the interest. That user does not need to be a specialized person. It could be anyone interested in a certain topic or a certain area. Once he fires a methodology, the data collection starts. The data enrichment, as I just explained to you in the diagrams, happens. Then you have the street network, you have the socioeconomic data. The urban graph is constructed. You generate the visualizations, and then you feed that into a natural language momentum where the platform, the model will generate the interpretation in a very plain and simple words and give it back to the user. The user at that point, it's totally free to start this conversational process and replies with a query or replies with a different question that feeds and goes back to the visualization, which is again interpreted based on that question by the user. And at that time, the user inputting the questions or inputting the metrics or whatever is an interest creates metrics of success that are used in the training of the natural language processing model, as you see in the top. Now, a very important part of this, which is the beginning of all the process, is the theoretical background. So pretty much the natural language model, it's not really just operating on its own basis or with its own parameters, but it's pretty much trained on this theoretical background that was initially trained and fed by the specialized users. So once this whole thing is put together, anyone can use this, and the natural language model can use as this interpreter that breaks it down the complexity of complex spatial questions and allows the user to have access to complex levels of research. In a nutshell, what happens here is in the traditional analytical process, the problem exploration, you don't have enough time, or the time for the problem exploration, it's almost half and half, and sometimes even less than the process of analytics. All that heavy software-based process, because of gathering the data, making sure the data is correct, stabilizing that data, then feeding that, then representing, and then interpreting, takes a lot of time. In the AI-assisted analytical process, automated, the time for exploration and to change the questions and make new questions or getting questions from the general community, it's much bigger because the process of analysis is compressed into this automated and conversational process. So to then tie this whole thing to the Chinese stadiums, we're going to look out of all those visualizations in two levels of visualization here. This is the first one. This is made specifically for the Chinese stadiums. We are looking at the socioeconomic activity, as you see in the top, the graph distance from center. So how this socioeconomic activity, which is all the dots, classified by this legend at the bottom, where they fall in terms of specific distance intervals. On the right, we have this walkability analysis where the two polygons, the blue one represents walkability, the orange one represents linear distances. The more they overlap means the efficiency of the whole network in terms of walkability, it's higher. Then in the bottom, what we see is based on each category, how the categories are distributed in the distance intervals that we have in the bottom. The left, the more it is to the left or skewed to the left, closer to the center it is. And the center, as we know, are those large buildings that were built in these African countries, mostly African. Here we have a walkability analysis. So each one, the interval, the colors of the interval mean 5 minutes. And what we see here on the right is a map that shows the distribution of those polygons and the points. To the right, what we have is the distance intervals and how they fall, how each one of those places fall within the intervals. And in the bottom, pretty much how the cumulative or the accumulation of those places happen as you walk away in terms of time, and the most common types that happen in the area. So this is automated. You click the button, this happens, you know, and we click the button, this happens in terms of each one of the Chinese stadiums. What we want to see now is this gives us two possibilities here. As I said, we can scale this up. So in this case, we have 20 stadiums. And in the same scenario, we can do 40 stadiums, or you can do at this stage with this level of automation. We can run this kind of analysis and gather this type of information in a lot of stadiums, or scale this up, right, to the sample that interests the problem. And at the same time, we can extract establishing this conversation with the natural language processing model. In this case, the question here is asked in terms of potential. So after the visualizations are generated, we run this on the trained model and ask the model to give us back a ranking, showing us, you know, which one of the two, rank the stadium based on the potential of creating some urban regeneration. So the meaning of the word here is super important, and we're going to see this later. Then this is how the natural language model ranks the 40 stadiums that we analyzed. Initially, we're going to look into these. Ask you to forgive me for the amount of text, but it's super important for us to see how this conversational aspect happens. So what we're seeing here is pretty much the visualizations that we saw before, put it on the left, and the natural language model responding to those visualizations. It understands that the reason why this one is the first one, or the one with the most potential, is the high walkability, the significant overlap between orange and the blue polygon, the dense clustering of amenities, the diverse range of amenities, the variety of amenities that happen near the stadium, the strong integration with the urban fabric, it's well connected, robust network, and transforms the stadium in a central hub, and concludes saying that this stadium is the best one because of the high walkability, the dense and diverse amenities, and the strong integration into the urban fabric. And the second one, once you go there and ask for an explanation, but why you think this is, or give me a reason why this one is the second one, it understands it has a moderate walkability. So we start seeing some nuances in there that's so hard to see with the naked eye. It's a moderate overlap between the two polygons that I told you before. So we can visualize the small difference in terms of area between the two polygons, or the overlapping of the two polygons. The high number of accessible places, this has more than 5,000. However, it understands it has a diverse number of places in there, but towards the bottom, it starts saying that has a moderate integration in terms of the urban fabric, that does not really connect the stadium and the city around it. And it concludes saying that it has a lot of potential due to the large number of socioeconomic activity that happens in the area, but it could really improve this and explore all this potential if it improves certain areas, especially the center of its urban street network. If you stress it further, and if we stress the program further and asks pretty much to break it down in the key elements, it says that the first stadium, the top stadium, has high walkability, a dense clustering of amenities, diverse range of amenities, strong urban integration, and high regeneration potential. So the potential word here is super important. In the second stadium, it has a moderate walkability, a high number of accessible places, a diverse range of amenities, moderate urban integration, and in terms of potential of regeneration, it has a strong potential, but improvements need to be done in terms of walkability. Towards the bottom, it's when we pretty much go there and start this conversation saying, but I really do not agree. Could you go further and explain it better? Why do you think? And give me some straight to the point questions or reasons why you think one stadium is better than the other. And then it's super interesting, and I highlighted pretty much the key elements in this conversation, which is it's pretty much defending that the first stadium is better than the second because of the quality of the accessibility, the urban integrations, the walkability around the first stadium is far more efficient and with direct pedestrian routes and more concentrated amenities within shorter walking distances. It understands that the walkability in the Dashharat Stadium and the efficiency of its urban integration give it a stronger potential to anchor urban activity making it more impactful urban hub than Phnom Penh, despite the later having more places around it. So the question here was pretty much, the confrontation was pretty much saying, hey, but I have more places in this one, which normally would be this one dimension that the human eye would capture. We would probably just look at that and say, well, we have more places. But in this scenario, as you see, it has those nuances behind the scenes that's so hard to be understood by the human eye. Now, if we look at the bottom two real quickly, looking at the same kind of analysis from the top down, it shows that it has, this one is the second from last on this kind of scenario when the question is potential. So looking at this one, which is the second from last, it says it has poor walkability, it has a sparse clustering of amenities, a limited range of amenities, it's a weak integration with the urban fabric, and it concludes saying the urban network around the stadium, it exists, but does not really generate anything. Now, once we look at the very last one, it says it's very poor walkability, the scattered, you pretty much see on the images on the left that you have nothing, right? It's just a stadium out in the middle of nowhere. There's no connection with the urban fabric. In its case, it's saying that there's a scattered cluster of amenities. It's a minimal range of amenities, a very weak integration, and concludes saying that there's nothing happening here. Now, if we do the same stressing or very few less slides, again, in the top, it pretty much summarizes what we saw in the previous images. And you see in the image on the left that pretty much the second from the last stadium, it has some type of street network around it. It has some connection with the street, so it has some intention to design something. The one at the bottom, which is the very last stadium, it's just a stadium in the middle of nowhere. So China, one of these, it's really not really perceiving as these stadiums are putting together this connection, or it's not really worried about this connection with the street network. But the bottom stadium is pretty much a case that highlights this kind of approach. Now, the important thing is, as you see the gray box here in the bottom, when you go there and you stress this conversation and change it, not just from the potential, saying, well, which stadium has the more potential to become a urban node? And in this case, the potential in the top one exists because you do have the street network, right? There's no potential happening here because nothing happens in the bottom stadium. Once you go there and say, well, just tell me which stadium is the worst. So once you change the potential to the worst stadium, the answer changes. And this is something that were really surprised by the level of perception, right? And how the natural language model can really understand this conversation experiment and change the meaning of the answer, allowing the user, following the user, right? Or pretty much allowing the user to see the complex question that we are asking here about what is the impact of these buildings.
Sorry, Gustavo, you have to conclude.
This is my very last slide.
Thank you.
So once we are in this scenario and we ask that, we see that what happens here is when we ask which one is the worst, it says that the worst stadium is in reality the top one, because the top one, as we're saying here, it represents a missed opportunity. So I think this is like, this gives us in this very last slide, what we understand, what we see from this relationship with the natural language processing model. It's able to establish this conversation and tackles extremely complex spatial problems, right? Where this is going, we aim this to become a platform, right? So everybody can use it, so probably can share this with you in the future. And with that, I pretty much conclude our presentation, understanding that we are trying to improve time to formulate answers, right? Or to improve the time to formulate answers with more time to make questions. Thank you very much.